Okay, so we've all seen what generative AI can do, right? It can whip up these incredible stories out of thin air. But what happens when you hand it the keys to a Dungeons and Dragons game? Well, you get some amazing off the wall creativity, and let's be honest, you usually get complete chaos. So today, we're going to tear down the blueprint for building an AI that's actually a trusted co pilot, not some rogue autopilot that just goes and breaks the whole game. All right, so here's our game plan. First, we'll talk autopilot versus copilot. Then we'll dive into the secret sauce, the truth versus ideas architecture. After that, we'll see it in action, talk about de-risking the whole thing, figure out how to make the AI smarter, and then wrap up with a quick briefing for the business folks. Let's roll? So this is it. This is the fundamental challenge. How do you get all that amazing creativity from an AI without it just going completely off the rails? Hallucinating rules, forgetting what the players just did, and basically shattering any sense of consistency. In this slide, this really gets to the heart of it. There are two ways to go about this. The autopilot approach on the left, that's the AI first way, and it's what leads to those flashy demos that are fun for about 5 minutes and then completely fall apart. The AI is in charge, so it wanders away from the story, it makes up rules, it forgets things, it's a mess. The co-pilot approach on the right, the engine first way. Now that is how you build a real product. Here, the AI only proposes actions. It's the core game engine that enforces correctness. That's how you get consistency you can count on. So how do we actually build that stable co-pilot? Well, it all boils down to one core architectural principle, and it's all about creating a foundation of trust. And here it is. This concept is absolutely crucial. This system draws a hard line in the sand. On one side, you have truth. This is the official, absolute state of the game. It's stored securely, and every single event is logged, so we have a perfect auditable history of what really happened. And on the other side, you have ideas. These are all the cool, creative suggestions from the AI. Narration, rulings, you name it. And the key is, they are treated as completely untrusted until our core engine checks them out and gives them the thumbs up to become truth. So here's what that looks like under the hood. You see that core engine? It's the boss. It manages the real game. The state, the rules, the dice, the map. The AI layer is super powerful for sure, but we keep it separate. It can only talk to the core through one single, tightly controlled point. It can't just reach in and start changing things whenever it wants. It has to ask for permission every single time. And how does it ask for permission? Through what is basically a strict digital contract. The AI proposes a command, but before that command can do anything, it gets checked against a JSON schema. You can think of this schema as the rulebook for what a valid action even looks like. Only if that proposal is structured perfectly and follows all the rules does it get the stamp of approval and become the new truth in our event log. Okay, enough theory. Theory's great, but let's see how this copilot actually performs in a real game. We're going to look at the 3 big gameplay loops you find in any tabletop RPG: exploration, social stuff, and, of course, combat. First up, exploration. Now, one of the biggest dangers here is what we call spatial hallucination. If you show the AI the whole world map, it might start describing this epic mountain that doesn't actually exist on the map. The solution is actually pretty clever. You only give it a little map window, just a small local slice of the map that's relevant right now. This totally grounds its narration in what's real and stops it from making things up. All right, next up, the social loop. So imagine an NPC guard dreamed up by the AI who shouts this classic line at your group. But see, here's what's really going on. The AI didn't just spit out some text, no way. It proposed a structured package of information. It gives us the dialogue, yeah, but it also gives us a machine-readable intent, in this case, block path. And it proposes a change to the game state, shifting the guard's attitude to hostile. The engine looks at this whole package, makes sure it makes sense, and only then does it become official. And finally, combat. This is where fairness is everything. The architecture uses specialized, predictable systems for this. The rules engine, it uses a cool tech called Retrieval Augmented Generation, or RAG, to look up the official rules and even cite its sources. So no more made-up abilities. There's a totally separate dice service that handles all the rolls, making sure they're random and logged for everyone to see. And the NPC, it can only suggest tactical moves that the rules engine confirms are actually legal in the game. Look, this isn't just about making a fun game. It's about building a product that's sustainable and responsible. So let's get practical and talk about de-risking this whole thing from a business and operations point of view. Let's talk money, because cost is a massive factor here. Just look at this table. The price for just one 4-hour session can be all over the place. If you're smart about it, using a cost-effective model with lean usage, you might get away with just 25 cents. But if you're not careful and just hammer a premium model with heavy usage, that number balloons to almost $5. This is exactly why this architecture is obsessed with carefully managing every single token. So what does success even look like for a system like this? It's not some fuzzy feeling about how creative the AI is. No, we track cold, hard numbers. We're looking at things like schema validity. Is the AI's output structured correctly almost 100% of the time? Are its proposed commands valid over 95% of the time? And are we keeping those reality-breaking groundedness violations under 1%? This is what a trustworthy product looks like in the real world. And to protect that bottom line, you absolutely need strong financial governance. You have to build in things like rate limiting, budgets for each session, even quotas for each turn. This is so critical to prevent what the security world calls unrestricted resource consumption. It's a huge financial risk for any live AI product, and you have to guard against it from day one. Okay, so the system is safe, our costs are under control, but how do we make the AI even smarter over time? Well, this is where the real beauty of this architecture kicks in. A solid roadmap is everything. And I want you to notice that first phase. We build a playable core with no AI at all. Get the stable engine working first. The state, the commands, the maps. Then and only then do you add the AI assistant with all its safety guardrails. This engine-first philosophy is how you build a real product, not just another brittle demo. And this is the magic. The system creates a self-improving data flywheel. Think about it. Because every single action in AI suggestion is validated before it becomes truth, our event log becomes this perfect, pristine source of high-quality training data. We're not logging junk, we're logging thousands of perfect examples of valid gameplay. This creates a long-term, compounding advantage that just gets bigger and better with every single game that gets played. Now, for all the MLOps people out there, you've basically got two main ways to go about that fine-tuning. You can use a provider's API. It's simpler, the billing is predictable, and it's great for moving fast. Or you can get your hands dirty with an open-weight model using a technique like QLoRa. This gives you way more control and is surprisingly efficient. And even if you're not a techie, this choice matters because it directly impacts how fast the AI can improve and how much it's all going to cost. Okay, let's tie this all together. For anyone thinking about the business side of things, here's the high-level briefing on why this architectural approach is so darn powerful. So, what's the big takeaway? This co-pilot strategy gets you a stable product, not just another brittle demo. It follows a de-risked roadmap that puts the fundamentals first. It's got safety and cost controls baked right in from the start. And maybe most importantly, it creates that incredible data flywheel, which guarantees the product gets smarter and better with every game played. And that kind of leaves us with a much bigger question, doesn't it? This whole truth versus ideas model with its strict validation and its data flywheel, it works brilliantly for gaming. But could this be the blueprint for how we build all responsible next-generation AI products? Makes you think.